In this lecture and module more broadly, we will talk about how wholesale electricity markets can be competitive. So the agenda for this section is a quick review of what we've covered in electricity so far and supply and demand in restructured electricity markets. So let's quickly review what we've covered. There's four segments of the electricity industry. Generation. Generation is conversion of fossil fuels or nuclear fuel, running water, wind, or solar energy into electricity. There's transmission. So we take what the generation units produce and we transmit it. These are the large electricity lines that you see along the highways and so forth. They're high voltage transportation of electricity from generation facilities to the local distribution networks. Then we have distribution, so we have stations where we ramp down the voltage from the transmission, and then we go to low voltage delivery of electricity to the final customer. That's the distribution portion. And then finally retailing, the sale of electricity to the final customers, billing users, collecting payments, financial contracts, etc. Some special characteristics of the electricity industry include: 1, demand must equal supply at all times. We have no storage of electricity, so whatever there is for demand, supply has to meet that at all times with very little wiggle room. Storage of electricity is very difficult. That's number 2. Number 3, generation of electricity is subject to severe capacity constraints. If you have a coal plant, you can't just ramp it up past its capacity. It can only produce up to a limited amount, and it's usually producing near that capacity. Number 4, real-time demand for electricity is extremely inelastic. We've talked about this. That's because retail prices are fixed, and so consumers have no incentive to change their consumption at any particular time of the day based on what's happening in the wholesale market. Number 5, electricity must be delivered through a transmission network that is also subject to capacity constraints. So we may not be able to get electricity routed to one place through the standard transmission lines because the transmission lines are completely full, so we have to go around them. How was the electricity industry organized? The electricity industry has been traditionally organized as a vertically integrated monopoly. We saw that there were economies of scale in producing electricity because it cost less on average to produce electricity with a larger generation plant than several smaller ones. Regulators then set the price paid for electricity. In other words, the wholesale prices were fixed and retail prices were fixed. The rate of return regulation that we've seen creates little incentive to cut costs because the only way to increase revenue under these types of regulations is by increasing expenditures. So let's think about this for one sec. If you're a generator and the prices that you're allowed to charge are regulated by the local electricity board or whatever they call themselves, if those prices are fixed and regulated and they're based on your average cost, then your incentive is to increase your average cost. In other words, basically investing in more capital, or the bottom line is you have no incentive to reduce your costs. What led to the recent wave of changes to this industry model? Well, generation no longer was seen as a natural monopoly. Advances in generation technology reduced the economies of scale in the industry, so you could build several small natural gas plants, for example, that could take the place of one large coal plant. Advances in transmission and information technology increased the distance over which electricity could be transmitted, so we could expand the grids essentially. So we might have electricity that's demanded in Ohio but produced in Illinois now. So the essential component in electricity restructuring, what we are talking about here is an introduction of competition in generation. So in the past, the generation was a vertically integrated monopoly. That's what we saw in the last several slides. What we're talking about here is that we're restructuring the market so that the wholesale part, the generation part is becoming competitive. Instead of one firm owning all generation plants, it may be possible for multiple competing firms to own generation. That means private profit maximizing firms have an incentive to minimize costs because they're competing against one another. They're not just going to the electricity board and showing them their average costs, and then the board is setting the regulated prices. Now we have firms competing against one another to produce at lower prices, which would theoretically lower costs for consumers. What else is required for there to be competition in electricity generation? With multiple firms, the coordination problem of when each plant should run becomes more complicated, right? Because you have multiple firms bidding supply functions. When each of those is going to be dispatched, it becomes more complicated. For competition to work, the coordination of generation and transmission operations needs to be independent. It can't be owned by these firms. So we transfer these roles to an independent system operator. So how do wholesale markets for electricity work? The independent system operator uses a wholesale market to coordinate the exchange of electricity. The market ensures that the lowest cost generation is used to meet the demand each period, subject to generation and transmission capacity limits. So what do we mean? There's an ISO, the independent system operator, that's taking all the demand information from all of the customers, aggregating it up to a market level demand curve, and then all of the supply functions from sometimes thousands of generators, and aggregating those up to an aggregate supply curve, intersecting the two like we normally do with a supply and demand curve, and getting the market price. And then any supplier that's below that was willing to supply below that market price is then dispatched, or they produce electricity and they receive some revenue for doing so. And any generator that was willing to supply at a price higher than that then does not get to be dispatched. So firms, here's a little more detail. Firms submit offers to generate electricity. Each day, firms submit to the market operator their willingness to supply energy for each hour of the following day. They do this on an hourly basis. Their willingness to supply or offer curve is a step function consisting of pairs of quantities and prices for every power plant. So let's take a look at this one. This is for firm 1, firm 1's offer curve or supply curve. So let's say firm 1 has about 920 megawatts. That's the first horizontal piece of this supply function. 920 megawatts they're willing to supply at $0. They're willing to supply that for free, essentially. And then they have an additional 430 megawatts. That's the next chunk of this supply curve. 430 megawatts they're willing to supply at $60. And then they keep going up. And the next chunk they're willing to supply at $93. The next bit they're willing to supply at $140, and so forth. And that's their total capacity that's they're willing to supply in this aggregate offer curve for them. Now let's say we have another firm that's willing to supply different capacities at different prices, and this is their offer curve. So what the ISO is going to horizontally aggregate both firms' offer curves into an aggregate supply function. That's the dark blue line on this slide. So that's the horizontal aggregation of firm 1 and firm 2's offer curves. So firm 2 in this case is willing to supply 835 megawatts at $200. Firm 1 is willing to supply 1,650 megawatts at $200, and if we add on firm 2's offer at $200 of 835 megawatts, then we get the total aggregate supply at $200, which is the dark blue curve again. So it's the sum of the two, the sum of firm 1's offer of 1,650 megawatts and firm 2's offer of 835 megawatts, which gives you about 2,500 megawatts at $200. So here's the aggregate offer curve. That's what the system operator uses to determine the price. That's the sum of the two the two supply curves or offer curves from each firm. In reality, we're dealing with thousands of generators oftentimes, or hundreds of generators. So it's not just firm 1 and firm 2. It might be firm 1 through firm 100, and we're creating an aggregate offer curve based on those 100 different supply functions. Then we have a system demand at 4,400 megawatts. The intersection of the system demand and the aggregate offer curve gives us the price. So the system average price is $120 per megawatt hour. That's the intersection of these two curves. So why is the system demand vertical instead of sloped like a regular demand curve? Well, we said that the demand in electricity markets is inelastic. That's because retail prices are fixed. That's a key point I want you to remember. The demand curve in electricity markets is perfectly inelastic, and so the demand curve is vertical. So we know what the price is. It's $120 per megawatt hour based on the aggregate offer curve. And so firm 1 generates where the price crosses its offer curve. So everything to the left of this vertical dashed line, firm 1 generation 1500 megawatts, that's what the firm is producing. Everything to the left of that vertical dash line. Everything to the right does not get dispatched. So firm 1 could have done better if the aggregate or if the system average price was higher. So half of its capacity was not being used. Firm 2, it produced a lot more of its capacity. You can see there's only a little bit left over, a little bit to the right of this vertical dash line. So firm 2 generates 785 megawatts. Everything to the left of that vertical dash line gets produced. Everything to the right is left on the table. So it's a bit of capacity that's not being used. So next, let's look at an example on an example problem.